Part A. Use the binomial theorem to expand 8 minus 3x to the power of 1/3, where the modulus of x is less than 8 over 3 in ascending powers of x up to and including the term in x cubed, giving each term as a simplified fraction. So let's remind ourselves what the binomial theorem is. It's that formula there as it's given to you in the exam booklet. So we need to write it in the form of 1 plus x to the power n. So first thing we need to do is factorise that 8 outside. So if I factorise the 8 outside, I'll get 8 to the power of 1/3, because even though I've taken the 8 outside of the bracket, it will still need to be to the power of 1/3. The 8 divided by 8 is 1. And then the 3x divided by 8 is 3x over 8. Now, 8 to the power of 1/3 means the cube root of 8, which is 2. So I can replace that with the 2. Right, let's now use the binomial theorem to expand the inside. So our n is 1/3, our x is minus 3x over 8. So we'll have 1 plus m times x. Right, then we'll have n times n minus 1. So 1/3 minus 1 is minus 2/3, divided by 2 times 1, which is 2, times our x, or the minus 3x over 8 in this case, squared. And then we need to do one more to get our cubic term. So we'll have n times n minus 1 times n minus 2. So taking away another 1 here from the minus 2 over 3 will be minus 5 over 3. All divided by 3 times 2 times 1, which is 6. Times our x cubed. Right, let's simplify that. We'll leave the 2 at the front for now. The 1 will just simplify to be 1. Then we're going to have plus 1/3 times minus 3 over 8. So the 1/3 and the 3 will cancel out, and I'll get minus 1/8 x. Next, we're going to have 1/3 times minus 2 over 3. So that's minus 2 over 9, which will then get divided by 2, which will be minus 1 over 9. We've then got the minus 3x over 8 squared, which would become a positive 9x squared over 64. The 9's cancel out, and we just get left with the minus 1 over 64x squared. Right, the cubic term. We've got the 1/3 times the minus 2/3 times the minus 5 over 3. So the 3 times 3 times 3 will give us 27 on the denominator. The The numerator, the 1 times the minus 2 times the minus 5. Well, the two negatives will give us a positive, and the 1 times 2 times 5 will be 10. But then that's going to get divided by 6. So when I divide that by 6, I'll get 5 over 81, I think. Yeah, 5 over 81. Then we've got the minus 3x over 8 cubed. So the minus 3 cubed would be minus 27. And then we will have the 8 cubed, which is going to be 512. With the x cubed. Then just simplifying the 5 over 81 times the minus 27 over 512. So we'll get minus 5 over 1536 x cubed. Multiplying each of those terms by 2 now. We'll get 2 times 1 is 2. 2 times the 1/8 is 1/4. 2 times the minus 1 over 64 is minus 1 over 32. And then we'll get 2 times the minus 5 over 1536 will be minus 5 over 768. And this is my expansion for the 8 minus 3x to the power of 1/3. That's my answer for part A. Part B says to use that expansion with a suitable value of x to obtain an approximation for the cube root of 7.7. So the cube root of 7.7. Well, cube roots, that's just like me saying power of 1/3. So this is the same thing as saying the cube root of 7.7. So let me compare that to my expansion. Let me compare that, because it does say to use my expansion, so let's compare them. The 7.7 would have to equal the 8 minus 3x. So you might be able to say straight away what the x needs to equal. If you can't, let's just set up a little equation. Let's say that 7.7 equals 8 minus 3x. If we take the 7.7 away from both sides, we'll get 0 equals 8 take away 7.7 is 0.3. Add the 3x to both sides and divide by 3. So if x is 0.1, then this is 7.7. So if I substitute 0.1 into my expansion, I will get an approximation for 7.7 cube rooted. So 2 minus 1/4 times 0.1 minus 1 over 32 times 0.1 squared minus 5 over 786 times 0.1 cubed. Which, if I put that into my calculator and give my answer to 7 decimal places, I'll get 1.9746810. And that is my approximation for the cubed root of 7.7 to 7 decimal places.